Hello and welcome to my homework zero biostats. Here we'll focus on research for lower back pain treatment. So the article of choice that will investigate this is effects of osteopathic manipulative treatment and bioelectromagnetic energy regulation therapy on lower back pain by Alger et al., published on March 2nd, 2021. So what is the problem statement? Lower back pain is defined as this extreme pain in the lower area of the spine, strictly speaking below the rib cage. And it's one of the most prevalent medical conditions in the US, affecting over 3 million people every year. And it can cause severe quality of life issues. These can include physical limitations. The person can't perform daily activities, also emotional stress. The person can develop anxiety and depression, work limitations, work opportunities may be limited and they can't perform certain duties. Also, social limitations, they can't engage in some activities that they find desirable. And lastly, sleep disturbances, they can develop insomnia due to the pain. They wake up frequently at night. So we want to eliminate/reduce lower back pain. And this is what our research is looking at. The research article is looking at. So the motivation. Physical therapy can be a way to treat lower back pain, and that's what the researchers are investigating here. So there's two treatments that they're investigating: osteopathic manipulative treatment (OMT), which is a hands-on approach where the physician applies controlled pressure and stretches the muscles, which has been shown to aid in musculoskeletal medical conditions. The second treatment is bioelectromagnetic energy regulation (BEMER), and this is a form of therapy that uses low-frequency pulse electromagnetic fields to improve the circulation to certain areas of the body, which can relieve pain as well. Right. So the researchers, Olga and her colleagues, want to determine if a physical therapy approach to lower back pain can help reduce and alleviate some of the issues that are developed with lower back pain. So why have they chosen this approach? Well, generally speaking, physical therapy is a much better is preferred to surgical approaches because it's non-invasive. Also, there's much lower risk as opposed to surgery, which can cause complications to the patient's post the surgery. Also, generally, physical therapy can be easier and cheaper for patients. So our goal, the researchers' goal, is to prove statistically that physical therapy approaches such as OMT and BEMER can yield significant results and improve the quality of life of patients suffering from lower back pain. This can directly encourage physicians and patients to adopt these approaches, which is obviously a good thing as highlighted by the advantages. So what is the experimental design developed by Dr. Alger and her colleagues? Well, they have a completely randomized design. The treatment variable is physical therapy method, and they divide it into 4 levels: OMT, BEMER, OMT plus BEMER, and the control group. And the response variables are measuring multiple response variables to measure the success of lower back pain. So we're looking at quality of life improvement, lower pain, things of that nature. So the response variables include change in visual analog scale. So the study is taking place over a 3-week period. So we're going to measure these values at the beginning and at the end, and we're going to see the change or improvement or lack thereof in these variables. So response variables: change in visual analog scale, 0 being no pain, 100 being max pain; change in osteoarthritis index disability, 0 being no disability, 100 being maximum disability; change in SF12 physical health, 0 being very poor physical health, 100 being the best physical health; and then change in SF12 mental health, 0 being poor mental health, 100 being best mental health. And the subjects recruited, they investigated 77 subjects, assessed for eligibility. 42 were chosen, 2 of them withdrew. So they had 40 subjects in order to test their treatments. And as I said, the response variable were measured before and after a 3-week treatment period. And here we have a flow of the subjects. We can see that this is the complete randomized design that we talked about. We have our subjects, and they're randomized to the 4 treatment levels that we have. So there is a pre-intervention statistics that the Alger and her colleagues include in their research, and they're shown here. And one thing that I thought would be interesting to know is the confidence interval of shown, right? So they used here they use the sample mean in order to estimate the population So they use sample mean as an unbiased estimator and to develop the confidence interval. And what is the interpretation of this confidence interval? Well, with repeated samples, in 95% of cases, the true mean of the population would be within the calculated interval range. So whatever we have here. So statistical analysis, they're going to develop, the researchers conducted one-way ANOVA analysis, and they also measured mean and standard deviation. So, but before we do one-way ANOVA analysis, the researchers had to make sure that the assumptions are met for one-way ANOVA analysis. And what are these assumptions? Well, first, the patients selected are independent and randomized, and that's exactly what happened in the study. The response variables are normally distributed at each level of treatment, and this was verified by the researchers by the Shapiro-Wilk test. And the variance of the response variable are equal across all groups, so equal variance, and this was verified by a Brown-Forsyth test. So, what are the null and alternative hypotheses? Well, the null hypothesis is that for any of the response variables, there's no significant difference in mean of that index across the treatment across the different treatments. The alternative hypothesis is one of the treatments mean is significantly different than the others. And here we can kind of see excess index can be any of the response variables. So we'll have 4 null hypotheses, 4 alternative hypotheses for each of the response variables. And our decision rule, we will reject the null hypothesis if the computed value of VR is equal to or greater than the critical value of F statistics at alpha equals 0.05. So our significance level is 0.05. So going to the ANOVA results, for all response variables, the p-value was larger than the significance level 0.05, and so we failed to reject the null hypothesis. So what does this mean? This means that there is no statistically significant evidence to prove a difference in mean whatever index, so VAS, OSWAS-3 index across different physical therapy. And no, it's important to know that no F statistic was provided by the researchers. Also, another form of results can be seen here. This is the mean change. So initially, we saw the pre-intervention baseline. This is the change from that after 3 weeks of treatment. And we can see general trends. We can see that the best improvements generally were for the OMT plus BME group. So they had the best reduction in pain. They had the best reduction in disability index. They had the best improvement in physical health, and one of the best improvements in mental health as well. And here we have a graph developed by Dr. Alger and her colleagues showing the stats that we talked about earlier. And we can see that generally the biggest bar is for OMT plus BME, showing that it had different positive change from baseline after 3 weeks of treatment. So, general explanations why were no statistical significance shown. One explanation could be that Dr. Arger said that our control group showed unexpected beneficial results. So although the control group got no physical treatment, they actually improved quite a bit. For example, here we can see that for the visual analog scale, they decreased in pain by 10 points, which is significant. And so because of that, there wasn't no significant evidence. And this could be explained by the placebo effect, right? Or it could be explained by the fact that the sham BME could have given subjects a sense of relaxation that might have aided in seeing results. Some limitations of the study, there's a small sample size. Each level of treatment had n equals 10, the size of the stem. So small sample size, also high variability. If you look at the standard deviations, there was high variability. And lastly, second-year osteopathic students were used to perform OTM. So that might have caused some not optimal results. Thank you very much. Here are the resources, and thank you.